Okay, this is 2024 AP Calculus AB, the first free response problem. This is calculator active. And we have a table here. It says the temperature of coffee in a cup at time t minutes is modeled by a decreasing differentiable function c, where c of t is measured in degrees Celsius for 0 less than or equal to t less than or equal to 12. Selected values of c of t are given in the table shown. Approximate c prime of 5 using the average rate of change of c over the interval t greater than or equal to 3, less than or equal to 7. Show the work that leads to your answer and include units of measure. All right, so in order to do the average rate of change here, I'm going to say c of 7 minus c of 3 divided by 7 minus 3. So c of 7 is 69. C of 3 is 85. 7 minus 3 is 4. So I'm going to get negative 16 over 4, which would equal to negative 4 degrees Celsius per minute. Okay. Part B says use the left Riemann sum with 3 subintervals indicated by the data in the table to approximate the value of the integral from 0 to 12 c of t dt. Then we want to interpret the meaning of putting the 1/12 out in front of it. Okay, so let's do the Riemann sum from 0 to 12 first. Okay, so we go from 0 to 12, and we've got c of t dt is approximated by, so if we look at our first interval, we're going from 0 to 3, so the width of the interval is 3, and we want the left point, so we're going to use the 100 here, plus the next width would be 7 minus 3, which is 4, and we want to use the left point out of the two, so that would be 85. And then the final one, again, would be, in this case here, it's going to be 5. 12 minus 7, and then we want to use 69 as that point. Okay, so if we get our calculator out, we're allowed to use a calculator, so we would get 300 plus 4 times 85. 4 times 85 is 340, plus 5 times 69 is 345. So we would get 345 plus 340 plus 300, and we would get 985 as our accumulation here. Okay, so we've accumulated 985 degrees from 0 to 12 minutes. Now, what is the meaning of the 1/12? Well, what they've done here is they've put a 1 over b minus a out front. If we remember now, that is going to give us the average value of a function. So that means if we take our 985 and divide that by 12, we get around 82.083. And then this would be, in this case here, would be the average temperature in degrees Celsius. Okay, let's continue with part C and D here. For part C, for 12 less than or equal to t less than or equal to 20, the rate of change of the temperature of the coffee is modeled by c prime of t, and they give us the formula there, where c prime t is measured in degrees Celsius per minute. Find the temperature of the coffee at time t equal 20. Show the setup for your calculations. All right, so what I want to do here is I want to use the fundamental theorem of calculus. So what I want to say is that the integral from 12 to 20 of c prime t dt is equal to c of 20 minus c of 12. All right. Well, I know I'm going to be able to get that definite integral from 12 to 20 with my calculator, and I can see that I have c of 12 up on the table there, so that's 55. Okay, so if I do this part, this definite integral from 12 to 20 of c prime on my calculator, I'm going to get negative 14.0 0.67. Now I'm just going to keep that on my calculator because I need exact answers here, so I'm not going to round it, but I'm just showing you here. So that's going to give us a nice way to figure out what the temperature is at 20, so we can figure out what C of 20 is. So what we would do is we would just go to our calculator. I already entered the definite integral. Now I'm going to add 55 to both sides to solve for C of 20, and I get C of 20 is equal to 40.2329 degrees Celsius. Okay? All right, for part D, for the model defined in part C, it can be shown that C double prime T is equal, and they give us a formula here, for T greater than 12, less than 20. Determine whether the temperature of the coffee is changing at a decreasing rate or at an increasing rate. Give a reason for your answer. So what I want to do is I want to check the sign of the second derivative between 12 and 20. And I can see on here that no matter what value I pick between 12 and 20, if I put in a value for T here, this is going to be positive. If I put a value T here, this is always going to be positive, and then I'm squaring T on the bottom. So that means that the second derivative is positive. So C double prime T is greater than 0 when from 12, T is greater than 12, less than 20. That means that the temperature of the coffee has to be changing at an increasing rate. Okay? So we'll see the answers come out. If you think I'm wrong on some things and you want to leave a comment, please leave a comment. If you like this, please like, subscribe, and leave a comment. Thanks. Have a good day.